Hi everyone, welcome back. We continue on this list. Lastly, we learned about this DNN based face detection and recognition, and today we are gonna finish this object detection module. But there is one more thing which we need to check, which is common functions and classes. And here there is already only one function, which is group rectangles. This is a very important function in the case of if you have overlapping rectangles and you want to filter them. For example, in the cascade classifiers or even in YOLO kind of object detection models, in sometimes you have more than one rectangles which is surrounding the objects. So in those cases you want to eliminate the extra rectangles. For example, there is only one human, but in around that human there is already let's say 5 rectangles, so you want to get only one. So by the help of this function you can eliminate those extra rectangles. Okay. Also, not only for object detection kind of things, in the for example, for different kind of purposes you can still need these group rectangles functions. So we do not know which kind of cases we can meet, but yeah, you can need different kind of situations. Also, you still can need this group rectangles function. Okay, I'm gonna skip this part because in the code part we can understand more clearly. Here we just need to create a simple math, and mask is equal to just, let's create a simple black image, which is gonna be, the size is gonna be 300 to 300, and just say, let's say 3 channel image. And okay, then after that simply we can create couple of rectangles which is overlapping, so we can understand the logic. So first of all, let's create a vector. Since this function is gonna take vector, let's create a rectangle. Oops, CV rectangle vector, and this is gonna be my rectangles. Okay, after this is done, we can push some rectangles into this vector, to this array. Just all we need to do is just creating some rectangles, or we can directly just calling rectangles dot pushback, and here we can call the rectangle, and we can create some rectangles which is starting from, let's say, since this is 300 to 300, let's make it start from 50 to 50 point, which is x and the y points, and next is gonna be the width and the height accordingly, and make it 50 to 50. This is gonna be the height. And similarly around this, let's make 55, starting from 55. Let's create one more rectangle which has the same width and the same height. Similarly, let's create one more group in here. Okay, here let's say this is gonna be start 155 to 155, and like this. Okay, so we created 4 rectangles, and each of 2 are overlapping. Okay, after this is done, for just visualizing, maybe we can call imshow, and the input we can call it, and just show me the mask. And of course I want to also draw these rectangles into this max output. Okay, we can make a for loop, more easy to see all the rectangles also. So just rectangle, and inside rectangles, and here just draw me the rectangle, which is gonna be this one, taking first of all the image, which is this mask, and get the rectangle, and get the color. Okay, let's make it yellow, which is our favorite color, and thickness, let's say 1. Okay, this is done. We can directly visualize. Let's see how it looks like. Okay, we already have, but the these 2 are starting at the same point, so they are totally overlapping. Maybe we can decrease this to 150, so at least we see the differences. And also I want to see this bigger, so let's create 2 windows, named window, which is gonna be first input, and this is normal window, and I also need one more window for the output, so we can make it bigger so we can see the differences. Okay, we can check. Okay, this is our input. So you see these are overlapping. Just imagine, for example, in the case of the object detections, you have an object inside, but you have two overlapping rectangles around that object. Then the next one is we need to eliminate these rectangles. So we need somehow a middle of these two overlapping rectangles. For that, we are gonna need this group rectangle function, which is gonna be this one. Okay, this one. This overloaded function, but we are gonna focus to the first one first of all. Just we need to give the rectangles, and the threshold. This threshold is the for example, we can see also explanation in it says minimum possible number of rectangles minus 1. So since we have two rectangles currently, we can make it 1. So 2 minus 1, because the number of the overlapping rectangles minus 1 is gonna be the threshold. For the high number, we can also change, and we can see how it's adapting. This epsilon is important. We can start with the default one, but we are gonna talk about it also. After this is done, we already get our rectangles since we are giving as addresses. So here we are gonna get the new ones, and for this I want to draw to a new math. So in here we can create a CV math output, just maybe just mask.clone. Okay, so to this one I can draw the new rectangles here, and also I want to maybe simply just check how it looks like, so we can see in the console also. And sure, we need to import output and output. Okay, let's run it again. So this output, so this input. You see there are two rectangles here, but the one is at the end. Also the starting point, maybe we can check. This is gonna be the middle of that two rectangles. You can check here x and the y axis, and here you see 52 to 52, and here 50 to 50, and here 55 to 55. So it's in the middle 50. So since there is no double pixel axes, so it's making it 52. So this is giving me the rectangle which is between them. Okay, so also at the end you can see how they are. So only two rectangles now we have. We eliminated two others, so from 4 filtered to 2 rectangles. Also, if you increase the number, let's say 60, maybe 65 will not be recognized because of the epsilon. We can check that also. 45, let's say. So you see even 3 you are drawing, now you still get 1, so it's eliminating. Let's now talk about this epsilon value. This epsilon is important. We are giving currently 0.2. This 0.2 is meaning maybe we can open also to understand. Just remove this one. Okay, this 52 0.2 means, for example, the width of this rectangle is 50, right? So 0.2, if you multiply this 50 with 0.2, you are gonna get 10. So 10 pixel is the interval which this the other overlapping rectangle can be far from the original one. So currently this is approximately, I can say, maybe lower than 10 pixel. So but to understand more easily, just make it 50. Just also remove this one to understand more easily. And currently this rectangle and this rectangle, there is between them there is only 5 pixel. Our threshold is 0.2, which is, if you just change with the height 0.2 times 50, you are gonna get 10. So it's lower than 10. But if you make it let's say instead of 55, 61, which is 11, which is far from the 10, you are gonna get at the end 0 rectangle, because somehow you are filtering again with the epsilon. So this is it's gonna recognize anymore this is not overlapped. But if you make it 59, which is lower than 10 according to the calculation, you are gonna get this filtered output because it's lower than 10, the distance between these two rectangles. This epsilon was important in that point. Yeah, this group rectangles also mostly used for object detection, detect the rectangles to eliminate them, but in some other situations, for different kind of purposes, you can still need these group rectangles. It's just keep in mind this is filtering the rectangles which are overlapping. That's all. Okay, for this video I just want to talk about this, and by this I think we finished this object detection modules. See you in the next videos.